Hello, my name is Jaden Cranmore and welcome to another week of Anatomy at SI. Today we'll be looking at Laboratory 10, which covers the endocrine system and the different structures pertaining to and surrounding the heart. Let's go ahead and dive in by looking at the table in the back of our manual, which shows all of the different glands and hormones that they release, and then we'll go ahead and dive into the heart. So if you're using the 2023 lab version or lab manual version, or if you're using a manual that's similar to it, you should go to the back of it and look at page 68 and 69, because it has literally all of the hormones and glands that you will ever need to know, right? It's got the different glands, as you can see, like the pineal gland up there, releasing melatonin. It even tells you the target tissue and its function within the body, right? And if we flip back over to our Laboratory 10, we can see that it follows right along, right? Pituitary gland, neurohypophysis, and adenohypophysis. We flip back, first ones, right? Neurohypophysis, adenohypophysis. It follows and tracks right along with that manual. So utilize this resource, right? Use the back of the lab manual to help you fill out some of those different, glands and hormones in Lab 10. Alrighty, so now we're looking at one of the models that we have for the heart, and the first thing that we need to do is kind of start orienting ourselves and figure out just where different structures are on this macro structure, right? So first thing that you need to know, apex and base. That's going to be how we kind of figure out whether we're on the top or the bottom, right? The superior or inferior aspect of the heart. So if we're talking about the base of the heart, we're talking about this upper region, right? Base of the heart is going to be this upper or superior region, whereas the apex is going to be this lower curved arched region, right? Here's the apex down here, and here's the base right up here. All right, let's go ahead and break inside of the heart. So I'm gonna, right? Now we're looking at the interior of the heart, the internal. First, we've got the atria. The atria are above the ventricles, so they're gonna be right here. There's the, before we continue, remember that when we're looking at this structure, right, we have to refer to everything as patient's view, or as coming from this individual. So my right is over here, and my left is right here. But for the patient, right, this is right, and this is left. So if we're going to look at the right atrium is going to be right there, right? On the right side of the heart, because we're looking from the patient's view, right? It's all about perspective. So we've got the right atria right here. We've got the left atria right here. Inside of the atrium, which is not pictured right here on this model, we've got the pectinate muscles. The pectinate muscles are these small finger-like muscles just kind of on the sides of the atria that help it contract and conduct those electrical signals. The other structure inside of the atria that we want you to know is the interatrial septum, right? Septum is just a dividing tissue between two spaces. And so we've got that interatrial septum that's just between the atrium, right? So there's a septum that divides these two atrium into their separate category or their separate spaces. And that's exactly what that interatrial septum is, right? Just splitting these two spaces. All right, let's go ahead and dive into the ventricles. So the right ventricle is on this side, right? Patient's view, right ventricle here, left ventricle right here. The right ventricle is going to be slightly smaller and less muscular than the left ventricle, and that's because the left ventricle is actually pumping blood all the way through the body, whereas the right ventricle is only pumping blood to the lungs, right? And so it has to work against a lot less resistance than the left ventricle does, and that's why left ventricle is much stronger, right? It can withstand much more force. All right, inside the ventricles, let's look at the chordae tendineae. Can't actually see them on this model, but they are these little tiny like tassels or tendons that connect to the muscles of the ventricle and help hold the valves open and help them shut, right? And so we've also, or the valves of our heart. We've also got the papillary muscles. Those are going to be these guys right here, right? Those are the muscles that attach to the chordae tendineae and then attach up onto those valves. We've also got the trabeculae carneae, which are these little striated, they're like these striated regions or muscles in the back of the ventricles on the walls of it, right? On the very back of this model that help with that ventricular contraction, right? We've got the papillary muscles that hold on to the tendae or the chordae tendineae, and then we have the trabeculae carneae, which are at the back wall of that ventricle. Next, we've got the interventricular septum. The interventricular septum is just the septum that divides the two ventricles into their respective spaces. Right ventricle, left ventricle, divided by the interventricular septum. All right, let's roll through the path of blood. So, biggest things that you need to remember is that the two largest vessels that carry blood back to the heart, superior and inferior vena cavas, right? Inferior would insert back there. And these two vessels are bringing deoxygenated blood from the outside body back into the right atrium, and then the right atrium is going to kick that blood down into the right ventricle. Once the right ventricle contracts, it forces blood up into the pulmonary artery, right? It's called the pulmonary artery because it's carrying blood away from the heart, right? Arteries carry blood away, veins carry blood too. And so this pulmonary artery, even though it has deoxygenated blood from the body, is getting carried away from the heart to the lungs. That way it can be given oxygen from the lungs. That blood is then going to return to the heart via the pulmonary veins, via the pulmonary veins. The pulmonary veins carry blood back into, let's tilt this guy up. There's the pulmonary veins on the back, right? The pulmonary veins are going to carry oxygenated blood back into the left atrium. After this oxygenated blood comes back from the lungs and is in the left atrium, it gets kicked down into the left ventricle, which is that larger muscular region of the heart that is going to contract, forcing all of that oxygenated blood up and into the aorta, right? And then so it can circulate up and around the body. That's the path of blood. There's a few other things that you should probably be aware of, kind of like the valves that are found in between the different areas, right? We've got the right atrioventricular valve right here, the left atrioventricular valve on this side, right? Atrioventricular. Then the aortic semilunar valve will be covering the aorta, and the pulmonary semilunar valve will cover the pulmonary arteries. All right. So, feel comfortable with the path of blood? Now let's go ahead and talk about the vessels of the heart itself. Next, we're going to talk about the supporting vessels of the heart. This is how the heart is going to oxygenate itself. That way it can perform its muscular duty of pumping blood all the way around the body. So, let's go ahead and start with the coronary anastomosis. What does anastomosis mean? Anastomosis is just a term that means a collection of blood vessels that allow for alternative pathways. So if we look at some of these areas that have like multiple pathways for blood to get to the same tissue, right? If let's say there's a little blockage right here, blood can actually perfuse through, I'm gonna zoom in a little bit. Let's say we have a little blockage on this artery, right? Blood can still enter in and perfuse from this artery to help kind of keep that tissue alive. So therefore, the anastomosis is kind of just an alternative pathway for that blood. That way, the heart always has an ability to supply itself with blood, right? All these alternative ways to have blood go to the same spot keep the heart from being in a situation where it perhaps seizes up because it doesn't have oxygen to one spot due to a blockage. All right. Left cardiac vein is going to be down right inside of this model, right? Can't actually see it too well, but you can kind of see how that red artery is going up inside of the model, right? That interior portion, that's actually the left coronary artery, right? All right, so next we've got the anterior interventricular artery. Interventricular, this is an awesome word and it's super helpful for us. Right? If we find the two ventricles, we've got the right one right here and the left one right here. Interventricular is just going to be the artery that runs between the ventricles, right? So it's this red vessel right here. Next, we've got the circumflex artery, circum, right? Circum is a prefix that means circle, like circumference, right? So if we think circumnavigate or circumflexing around the artery, right? See, are you following with me there? Yeah, it's this vessel that wraps around the anterior to the posterior portion of the heart. And if we follow that, actually no, I don't want to follow that quite yet. For now, I want to go over to the right marginal artery. Right marginal artery is going to be on the right margin or right border of the heart, right? So remember, this is right, this is left if we're looking at patient's view. Right marginal artery is going to be just back here. And lastly, if we follow that, I want to come back to that circumflex artery, right? There's the circumflex artery, and if we follow that all the way around, see it goes all the way, it's kind of crazy. On the back, we have the posterior interventricular artery, right? Posterior interventricular artery is going to be right here. If we've got the left ventricle right here and the right ventricle right here, this is going to be that interventricular posterior interventricular artery, right? We've got an anterior interventricular artery right there. We're going to have a posterior one back here. Next, let's go ahead and talk about the different veins that we have that support our heart. And so these are going to be the structures that help pull blood back up and out of the heart after it's been placed there by the arteries, right? This is deoxygenated blood that's going to return back into the right atrium. That way it can be kicked around over to the lungs, right? All right, so let's go ahead and dive into the first structure. The first one is the coronary sinus. Coronary means heart, right? Coronary sinus, right back here. It's actually the largest of the veins found on your heart, right? Or the largest of the supporting veins, I should say. If you look at all of them, the coronary sinus is the largest on the back, and it's on the posterior aspect of the heart. Next, you have the great cardiac vein. The great cardiac vein is actually an extension of the coronary sinus, and it comes down in between the interventricular space, right? So we've got the right ventricle right here and the left ventricle right here, and that great cardiac vein is going to split down between them and actually pull up the blood that the anterior interventricular artery has placed there, right? So this great cardiac vein is just pulling up the blood that the anterior interventricular artery has already placed there. That way it can oxygenize the heart. All right, let's go ahead and look at the middle cardiac vein. Middle cardiac vein is going to be on the posterior, right? So we've got the coronary sinus right here. Just beneath it, between the ventricles on the posterior side, is the middle cardiac vein. So it's right in the middle of the two ventricles on the posterior side of the heart. It's easy to remember, the middle cardiac vein. Between the two ventricles, posterior aspect of the heart. And lastly, we have the small cardiac vein. The small cardiac vein is going to be this little tiny vein right here that kind of goes and wraps around the heart. And it actually helps to pull up blood from the right margin of the heart. Fortunately, this model is not going to show it for us too well, but you can still see where it starts, right there coming off of the coronary sinus. It'll pull blood from the right margin of the heart, bring it back up into the coronary sinus. That way it can be kicked into the right atrium, sent to the right ventricle, kicked to the lungs through the pulmonary arteries, brought back into the left atrium, kicked down into the left atrium, and then shot up through the aorta. That way that oxygenated blood can now go and perfuse throughout the body. All right, that's the freaking heart and all of its vessels and blood flow. Let's finish up by talking about the conduction system that keeps it all ticking. Alrighty, let's finish up with the conduction system of the heart. First, we have the sinoatrial node, which is the natural pacemaker of our heart, right? It contains those pacemaker cells that propagate the original signal that's going to cause the heart to contract. So the sinoatrial node up here is going to start that signal. It propagates down and around the right atrium until it reaches the AV node, or the atrioventricular node down here, right? And it sits right on this little septum between the atrium and the ventricle beneath it, right? The right atrium and the right ventricle. We've got the sinoatrial node propagating a signal down to the AV node, or the atrioventricular node. Next is the atrioventricular bundle of His. That's this little yellow connecting region right here. It's going to propagate the signal from the atrioventricular node down and into the atrioventricular septum. After that signal continues, into the interventricular septum. After that signal continues down into this area, it travels through a bunch of nerves called the bundle branches. These bundle branches are going to continue propagating the signal out and into the Purkinje fibers, which are in the walls of the ventricles. So think about it like this. It takes time for this conduction system to propagate a signal from right here all the way out to these portions, right? And that's why the atrium are going to contract first. The signal starts right here, causing the atrium to contract. It travels down starting at the sinoatrial node. It fires a signal, right, with those pacemaker cells, leading a contraction to go, or causing a contraction to go all the way down through the atrium until it reaches this AV node, right? The AV node is going to push that signal down into the bundle of His, which then carries the signal down and into the bundle branches, propagating it out or in around into the Purkinje fibers. All right, that's the conduction system of our heart. That's the last section. That's all of Laboratory 10, and I'll go ahead and see you for the next one.